Hi, I am Amy Leonard, and today we are going to look at a real-life application of using binomial probability. We're going to look at, we have a 10-question Scantron form over here. And let's say that you did not study for your test at all. You know absolutely nothing about what's going to be on this test, but you know you need to get a 60%. So walking into this test, what is the probability that you are going to guess on all 10 problems and get that 60% that you need? So as we look at this, there are three facts. We have a fixed number of observations. We have exactly 10 problems. We have the same probability of success in each of getting a problem right. So for each individual problem, because there's 5 answer choices, only one of them is correct, we have a 1 out of 5 probability of getting any individual problem correct. That is 0.2. That is our probability of success. That means our probability of failure on any given problem would be 0.8. And we're also going to say that each problem is independent of the other. Whether you get this problem right or wrong does not influence whether you get another problem right or wrong. So those three things being true means we're going to use a binomial probability. Let's look at this. In order to get a 60, that means you have to get 6 out of 10 correct, which means you are going to get 0.2 times 0.2 times 0.2. You're going to succeed exactly 6 times. And then you're going to fail, you're going to get 4 problems wrong. Okay, we can simplify this a little bit and we can say that this is 0.2 to the 6th power and 0.8 to the 4th power. Well, a lot of students would think that, okay, that's the probability of passing this test. But in fact, that's actually just the probability of getting the first 6 problems correct and the last 4 incorrect. That's not the only way that you can pass this test. You could also pass this test by getting 2 through 7 correct and then the other one's incorrect. Or you could get 1 correct, you could get 2 incorrect, and then you could get 3 through 7 correct. This is only the probability of one possibility. We have to look at all the possible combinations of getting exactly 6 problems correct. So we have to actually use the combination formula. So that takes us back to, we have 10 problems, and we are going to look at how many different possible combinations in which we can get 6 problems correct. So we're going to take the number of possible combinations, and then we're going to multiply it times our probability of success, and then our probability of failure. So all of these come together to form our entire equation. I got to calculate that really quickly. Okay, so as I type this into my calculator, I actually find that the probability of getting exactly a 60% on this Scantron, when you go in completely guessing, is 0.0055, approximately 0.0055. That is less than a 1% chance that you will go into this test, not have any knowledge of the topic, and manage to pass with a 60%. Now, we can take this and we can make a general formula so that you can determine any binomial probability. So this number right here, this 10, is the number of total possible outcomes, and we're going to call that n. Choose k. So k is the number of successes. Now 0.2, what was 0.2? 0.2 was our probability of success. That was our p-value. This 6 was the number of times that we needed to have that success, so we're going to put this to the k power. 0.8 was our probability of failure on each question, which was our Q value. And where did this 4 come from? Well, that's how many you get wrong. If there's 10 total questions and you get 6 correct, that's how we got our 4. So this exponent would be n minus k. And that is going to be our general form for calculating a binomial probability.